Hello guys, welcome back to lecture series on discrete mathematics. As INSEM and ENSEM exams are coming closer guys, we are going through very important points and topic in our lecture series. Okay, so in our today's video guys, I'm gonna explain to you from relation chapter reflexive closure and then symmetric closure and transitive closure. These are very much important guys. Maybe you will get the definition in your exam, or you will get the Warshall's algorithm, which is very much important for transitive closure. Okay, so for that particular we are going to learn these closures in our today's lecture. Okay, so without further ado guys, let's get dive into our today's lecture. I'm going to explain to you all what actually the reflexive closure is, okay, with examples. So most of the students are confused with this definition. Okay, so that's why I'm taking it separately. Yes, so let's start. Let R be a relation. Okay, so we are taking relation R be a relation on a set. Okay, let me explain reflexive closure. Okay, let R be a relation on a set A. I'm taking set A. Okay, I'm taking set A. R be a relation on a set A which is not reflexive relation on A. Okay, R is a relation but which is not reflexive relation on A. Okay, which is not reflexive on A, which is not reflexive on A. Okay, not reflexive means there is no element available that they are related to itself. Okay, maybe available but not all the elements are related to itself, then we say that it is not reflexive. Okay, not reflexive means A related to A, if is there then we say that relative, then B related to B, then we say that it is a reflexive, but all elements should be there, then we call it as the reflexive. But A is not related to B. Okay, so we cannot write this one. Okay, A is not related to B. A is not related to B, so this one is not reflexive. Okay, so I hope you all have understood the not meaning for not reflexive. Okay, yes. Okay, so we can write now this is not the reflexive. Okay, but we can write a new set. You can write new set. Consider that set P. I'm writing set P again. Okay, what the set P can say? Set P says that this relation R, which is not reflexive but which is the relation. Okay, not reflexive but the relation, we write this one as R union delta. Okay, R union delta. Okay, is called reflexive relation. Okay, this one called reflexive closure. Okay, reflexive closure. Okay, but most of you are thinking that what I have given here, what is the delta? Okay, now let me explain what is the delta. Okay, delta is a minimum number of order pair which satisfy reflexivity property. Okay, delta, what is the delta? Minimum number of order pair. Minimum number of order pair. Okay, minimum number of order pair, but all should have reflexivity property with reflexive property. That means delta has all the element which are the reflexive. Okay, reflexive, hold the reflexive property. Okay, so let me explain with one of the example guys. It is very easy. Okay, first R is a relation but which is not reflexive on that set. Okay, reflexive not means this is the condition. Okay, and we are writing new set P as R, that set R union delta for that entire set we call the reflexive closure, and delta is a minimum number of order pair which has a reflexivity property. Okay, yes, let me explain with one of the examples so concept will be the crystal clear for you all guys. Okay, let me take set A. I'm taking set A over here. You can consider any set. I'm taking small set ABCD. Okay, set A I consider ABCD. Okay, relation also consider that it cannot hold, okay, reflexivity property. Okay, so you can take a, okay, then AB, then you can take a CD, again you can take a C and C. Okay, so as we can observe here, okay, R is the relation but which is not reflexive. Why? We have A is related to A present, but B is related to B. It won't be visible here. That means B not related to B given. Okay, that means order pair BB not there. Okay, order pair CC is also there, but order pair DD also not there. So D is not related to D. That means these two order pair absent, BB and DD are absent, so that R is not reflexive. Not R is not reflexive. Okay, R is not reflexive relation. Okay, so if R is not reflexive relation, so we can define new delta. Okay, we can define new delta. Okay, so you can define new delta in a such a way that, okay, a small number of element we have to consider for the delta. Okay, minimum number of order pair in delta. Okay, let's write the delta here so that R can be the reflexive. Okay, so what we have missing, BB and DD, these two order pairs are missing, so I'm adding order pair BB and order pair DD. Okay, these are the two order pair as a delta. Okay, now what we have, new set P as a R union delta. Okay, let me write P set as a R union delta. Okay, R union delta. So what is the set R? R is the set here A, B, C, D, C, C. Okay, let me write A, B, C, D, C, C. Okay, these are the four sets, and delta BB, DD. Okay, BB and DD. Okay, so you can see that this is the delta, this is the R. I have taken their union together here as a set P, and if you can observe set P, it seems like that set P is hold reflexivity property. Now you can see that A is related to A, B is related to B, C is related to C, and D is related to D. Okay, so all four elements are related to each other. Okay, so this one we call this set P. P is the reflexive closure. Reflexive closure. Okay, P is called the reflexive closure over here. Okay, I hope you all have understood, guys, what is the meaning for a reflexive closure. Okay, so you can refer this entire definition. It is important. In our next lecture, guys, I'm gonna explain to you all symmetric closure and then transitive closure. Okay, this is very important for today's lecture. Okay, so if you want, you can note it down. Still, if you have any doubt, difficulties, guys, let me know in my comment section. I'll come up with the similar videos. Okay, I hope, guys, you all have understood my today's lecture. Okay, so that's it for our today's lecture. So thank you everyone. Thank you for my today's lecture.